how are you doing today? I'm Hugo from TechCornerTV and I have a small project to share with you. It's my millivolt voltage reference board. As you know, I test a lot of equipment. At the time of the recording of this video, I have 5 under 19 euros or more or less $100 oscilloscopes to test and review. And even today arrived the new VNIRSI DSO TC2 to test also. Through all these tests and reviews, I realized that I needed a stable millivolt voltage source supply that will allow me to test different equipments, always with the same conditions. I have an awesome Rigel power supply. Can't be happier with it, but even so, I decided to create my own reference board, especially targeted to lower voltages. As a disclaimer, some of you probably know I'm a hobbyist and my academic formation is on IT, not electronics. So I investigated the best way to do this and came to the conclusion that voltage dividers will be a nice way to do it. If you guys have different methods, a better way to do it, or just ideas to improve this project, please let me know in the comments. But enough chit-chat, let's do this. Okay, so what is a voltage divider circuit? I will base my explanation on this page of Learn About Electronics. I think it's quite clear. I will leave the links on the description if you want to take a look. And you have here the schematics for a very simple voltage divider circuit. And it goes like this. We have the input here with 5 volts. We have 2 resistors in series. And we have the ground. In the middle, we have an output voltage that will be different according to the values of the resistors. In this example, since the resistors both have the same value, 10K, we will have a drop of exactly half of the voltage. There is a reason for that. We have here a formula that will show you how to calculate the voltage output, and it goes like this. You have the voltage in multiplied by the resistance of the resistor 2, all of this divided by the sum of R1 and plus R2, that is the resistance of resistor 1 and the resistance of resistor 2, and that will give you the value, the value of the output. If you want to find out what will be the value of this resistor, you can specify also the input voltage, the desired output voltage, and the voltage of this first resistor. And you can, with these three values, you can find out what should be the value of the second resistor. For that, we have also here a formula that will show you that the second resistor it's found by multiplying the desired voltage out by the resistance of the first resistor, all of this divided by the difference of the voltage in minus the voltage out, and that will give you in ohms the value of the second resistor. You have here another example. For example, if you want to, instead of 2.5 volts, it's the half, you want to have 3 volts, the second resistor can be something like 15K, and that will make that the drop of voltage to 3 volts. If you want, for example, to drop it more, you just lower the second resistor, for example, from 10K to 2.5K, and it will drop to 1 volt. This page, it's very simple to understand. It's a very good resource. And you have here also a second schematic. It's basically the same thing. The formula is a bit different because the voltage it's in here instead of there, but it's only a visual stuff. The end result is the same. And for that, you have also a simulator here that you can put the voltage in, first resistor, and the second resistor, and it will calculate the voltage that the circuit will output. In this case, 25 millivolts. You have also in this other page, for example, how to do the same example, but with several resistors in series to have well, a more precise resistance values. To make the resistor selection easier, I programmed very quickly in 5-10 minutes a small script in PHP that I run here locally on my computer. As you can see, we can input here, for example, the voltage. It always works on the voltage of the first, the resistance of the first resistor, for example, 1 mega. We specify the input voltage, the output voltage, for example, I want to, 100 millivolts, and it will say how much it has to be the resistor 2. We can also insert the resistor 2. For example, if I put here 5100 volts, it will say that the output from 1 mega with this resistor will be 25 millivolts. And yeah, it does a small calculus only to make this process easy. Okay, the selection of the resistors is a very tedious situation, because you have several values that will give you the desired voltage or millivoltage in this case. For example, I have here 25.17, that is quite great for 25 millivolts, but to get there you have to take, for example, a resistor, use this device, because as you know, or as you should know, not all the resistors have the same voltage or that is mentioned. For example, this one is 1 mega and it says it's 10K. Okay, it passes a little the 1 mega. It's not much, to be honest. I saw worse in here. Let me see what will be the value of the second one. Okay, and okay, this one should be 5 mega, and it says it's 5099, so it's almost 5.1. The 25 millivolts that I have in here were achieved using a 3K resistor in here, and I believe a 47 ohms in here. So you have to see the correct values of the resistors. Let me see, for example, this says 25.16. Let's see how will be the voltage using this one. And yeah, give me some time to do this because I have some trouble seeing. Okay, this combination will get you more near the 25 millivolts voltage desired, and that's what I want, to be as near as possible of the desired voltage. For that, I analyzed each one of the resistance of the resistors. I put the values in the page that I just showed you, and I got some values. Okay, that's it. Let's pass this to a schematic to create a PCB. So the first thing I have done is to create the schematics for this. As you can see, we have here the pin with the voltage input, the ground. We have also 2 pins for the ground, one to connect to the output voltage and one to do the input. 7805 to convert the input voltage to 5 volts. 2 capacitors to stabilize the signal, and we have 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8 dividers, and one 5-volt output signal that comes directly from the 7805. It's a very simple design, so yeah, let's see how the board will be. And the capacitor, and also the L7805. It's a very simple board. Let's try and see it in 3D. Here we have it. As you can see, it's a very simple board. Nothing fancy. I just want the output voltage in here. Quite cheap to build. So now let's upload this to PCBWay and create a professional board for this project. So today's sponsor of this video is PCBWay. I would like to thank them for supporting the channel. Let's insert here the measures of our PCB. This can be always be adjusted after analysis. It's pretty easy, just put the measures, the quantity. You have several predefined, 2 layers, 1.6. Normally you just leave these on the default values. And you have here a few more options to fulfill. Unless you know what you are doing, just leave this on the default values. You can choose here the color of the PCB. As you can see, 5 boards will cost you $5. It's a pretty cheap price. I don't have right now the size of the board that I will order, but I think it's something like 100 mils by 70. It will be a little more than the basic boards, I think, or not. Okay, that's it. So most of the options are pretty straightforward, but if you are not sure what you are doing, just leave it by default. And you have here an immediate code. For me, for Portugal, I normally use DHL when I'm really with hurry on the boards, FedEx, or if I want to use something more economical, I use this one. It's 13 to 30 days. It normally arrives pretty fast, like 1 week, 2 weeks top. And yeah, but for example, if you are on United States, let me just show you. United States, you have pretty nice deals here also. For example, using the USPS service, it's 6 to 16 days. So with a bit of luck, you might get this after 1 week, 10 days, something like that. So as I told you, I'm in Portugal, so let me just go back. Portugal, opa. Yep. And I will choose this one. For $5, you will have 5 PCBs professionally made. It doesn't worth the time of designing yourself and preparing locally. Let's do it. Put in the cart. Okay, so I have here my Gerber file already in place. I will just move it and submit order. Yeah, that's it. Okay, let's wait some days for this delivery. Hey guys, so this arrived today. I'm pretty pumped up to see how the boards ended. Let me just open it. Yeah. Thank you PCBWay for supporting the channel and for sponsoring this video. Let me just see what is the final result of the boards. Very well packed. We have some stickers, thank you. And we have here the boards. Very nice. Yeah. So, yeah, let's see. Let's open and see. Yeah, very nice indeed. Look at this finish. Very good quality. Yeah. Again, If you want one of this, just go to PCB. I'm gonna leave the link on the description for if you want to buy one of these reference millivolt reference boards. Yeah. Okay, let's see the schematics and let's see if I made a mistake or not. So if you were paying attention while I was talking about this diagram, you probably noticed that I made a huge mistake here. Your jackass friend did something, I don't know why. I connected the capacitors all in the same line, so they both are connected to the to the live line, and of course this could not be. And the worst part is that I received the PCBs with this error. I already corrected the error, so we have connection to the ground now on the capacitors. And yeah, I will have probably to order this again. Also have here the layout already corrected, and I will make this available on the PCB website on projects. So if you want to order a voltage reference board like this, you are able to without any problem. Okay, after this facepalm moment and some digging, what I found out is that both these connections are connected in the same line, and this is the output. We have output in both places, and all the system is connected. So in the output I will not be able to use the capacitor, but everything is working. So the main problem right now is the connection between these two and this one. So also find out that I have connection from this one to this one and from this point to this point. So the solution for this problem right now is just shunt it. I will use a small shunt, and not using capacitors in this version, but anyway, it's just to give some stability to the signal. And yeah, I already corrected this on the layout. You have already online the new layout, and that will fix the problem. Just with this small shunt, we now have the power, for connecting the 7805. So right now what we need is to solder all the components, and let's see if this works. Okay. So right now it's the moment of truth. This device was engineered or thought to be used like this, with a probe. You connect the common or the ground here, and you can use the probe to use it like this in any of the voltages. Yeah, it seems to be okay for that, to test oscilloscopes. And yeah, right now let's see if it really works. I have to admit I did have some hiccups. For example, the 25 millivolts and the 500 millivolts were not working. I have to remove these resistors and solder again new ones. But after that, it seems to be okay. So let's do a final test and check it out. So I will connect here the ground or the common from the multimeter. Let me just see if it's, yeah, like this. And right now let's start with the 10 millivolts. Okay, so we have 10 millivolts. I will put this on millivolts, it's easier to see. We have 10.63 millivolts, and the good part of this board, it keeps always the same value. It's 64, 65. Well, it doesn't change a lot. It is missing here the two capacitors, as I explained before. I don't know. I made a mistake when I sent this to PCBWay with the layout with such an error, because when I opened the PCB, I look at it, I immediately understood that I made a mistake. So I don't know, it's one of those things. Let's now see the 25 millivolts, 25.26, yeah, pretty near also. We have 50 millivolts, 50.19, 100 millivolts, pretty damn near, almost perfect. So right now I will change this to volts, and we have here 248 millivolts, 0.6, so yeah, 249, it's almost there. We have also the 500 millivolts, 502.5. We have 1 volt. This one, the 1 volt, it's a little off, but yeah, it's almost there. And since it has always the same value, we can also evaluate 2.48 volts, 49 if we round it. And we have here the 5 volts. And on the 5 volts, I have here an issue, and maybe you guys maybe help me. As you can see, it doesn't say 5 volts, it says 2.7, 2 point something. I tested also with my oldest multimeter, this one, and it says this. I will not even test it, it says the same. But if I put this on my Siglent benchtop multimeter, it will really tell me the 5 volts. I don't know why those portable multimeters say 2 volts instead of the 5 or 4.86 or 87 they normally outputs. That's pretty weird. I don't know why. Maybe you guys can explain that to me, those that have more experience. I really don't understand why this happens. All the voltages are okay, even the 2.48, 49, but only this one, and this one doesn't pass over any resistor, comes directly from this source on the 7805 directly to here. And instead of saying it has 4 point something, it says it has 2.6. So if you have any ideas and want to spare some time to, well, teach me something, feel free. I'm totally good with it. I have already some ideas about improving this board. One of the things I didn't consider while using my simulator or my calculator for calculating the resistor values was the voltage output. And the voltage output, it's not really the voltage output, it's not really 5 volts, it's 4 something. And if we take that in consideration, there it is. I don't know why this says 278. In here we should have something like almost 12 volts, and this is totally correct. But the thing is, the voltage, it's not 5 volts exactly. So the next version, I will take that in consideration to calculate the resistor values, so it can be near the desired values. Also, so I will probably make, instead of only one resistor, the possibility of having two resistors, and if you don't use it, you just shunt it with a wire like this, and you will not need to use it, but it will allow me to go much closer to the desired voltage. If it is needed, no, it's just some perfection that I like to have in this kind of work. But for now, I will be able to start testing. I was able, but this will give me a platform to test different devices, always with the same voltage output. If you have any ideas to improve this project, or if you know a better voltage regulator than the 7805 that I can use in this project, a more stable one, just let me know. These capacitors I also saw on the internet on an article how to stabilize the voltage. So if you have any ideas that how to improve this to have a more stable signal, a more stable voltage across the board for this processing. So yeah, any idea is a good idea if it is to improve this. So that's it. If this video was in any way useful to you, don't forget to give a big thumbs up. And if you haven't already, please subscribe and hit that bell to activate all notifications and be the first one to be notified whenever I post a new video. That's it for today. Thank you for watching, and I hope to see you in my next video. Cheers!